Let us solve this first question, integral. Generally, this question appears as a direct application of formula. Means here it is tested whether the student knows the formulas or not. So these both are direct formulas. ये दोनों जो टर्म्स हैं ये डायरेक्ट इंटीग्रेशन के फॉर्मूले हैं जो जस्ट रिमेंबर करना है और उधर सिचुएशन में अप्लाई करना. एज यू नो द डेरिवेटिव्स का फॉर्मूला यहाँ लिखता हूँ. डेरिवेटिव्स ऑफ tan इनवर्स x क्या होता है? tan इनवर्स x का डेरिवेटिव्स है 1/1 प्लस एक्स स्क्वायर. सो इसको रिवर्स में अप्लाई करेंगे तो इंटीग्रेशन ऑफ 1 प्लस एक्स स्क्वायर इज नथिंग बट tan इनवर्स x. और इसी तरह डेरिवेटिव्स ऑफ a रेज़ टू x होता है. डेरिवेटिव्स ऑफ a रेज़ टू x इज a raised to x multiplied by log. And as you know, the integration is exactly opposite to derivatives. Integration of a raised to x is a raised to x upon log. So therefore, this will be 5 raised to x upon a is 5. That's why it will be log 5 plus c. C is for constant, because this is the integral of indefinite type. So we are not given with the limits of integration. So this is the only step we have to take. You will get half mark, 1 mark for one correct formula and another 1 mark for another correct formula. So this is question 1b. Let's solve it. We write it as an integral I is equal to integration of tan square x. Now, as you know, there is no direct formula for tan square x. We use trigonometric property relating tan square x with sec square x. We know 1 plus tan square theta is equal to sec square theta. So this will transform into tan square theta हो जाएगा sec square theta minus 1. तो इस प्रॉपर्टी को हम यूज करेंगे इसको सॉल्व करने के लिए. तो it will be integration of sec square x minus 1 into dx. And we have sec square x integration. As you know, derivative of tan x is sec square x. So integration of sec square x is tan x. And for minus, integration of 1 is x plus c. This is the final answer, tan x minus x plus c. So this question 1c, this is from the chapter definite integration. We have been given limits. इसमें लिमिट दिया गया 1 to 2 dx upon और इधर लीनियर टर्म है. तो इसको सॉल्व करते हैं. I is equal to integration of 1 to 2 dx upon 2x plus 11. Now here we will use this general formula, integration of dx over ax plus b. The formula is log of ax plus b into 1 upon coefficient of x is a. This is the formula. Plus c is for indefinite. Now here we have definite integral, so we will not use plus c. This will transform into log. इसका बनेगा 2x plus 11 into 1 upon 2. A is this coefficient of x. और इसको लिमिट अप्लाई करेंगे 1 to 2. अब इसमें 1/2 is a constant term. We can take it out of bracket and then apply limit to this term log 2x plus 1. So applying limit will be upper limit minus lower limit. So जहाँ जहाँ x है वहाँ 2 replace करेंगे. 2 into 2 plus 11 minus again lower limit. Lower limit will be log of 2 into 1 plus 11. This is, we have applied the limit. Definite integral limit is applied. So simplifying, this will be log 2 to the 4 plus 11, 15 minus it will be log to 13. 2 into 1, 2 plus 11 will be 13. One plus. So further simplifying using the rules of logarithm, final answer will be 1 by 2 log m upon n, that will be 15 by 13. This will be the final answer. This is the question 1D from the question paper of summer 2024. Here we have been asked to find order of degree. like ऑर्डर और डिग्री फाइंड आउट करना है. तो ऑर्डर और डिग्री का जो डेफिनेशन है उसमें कंडीशन ये है कि द इक्वेशन शुड फ्री फ्रॉम रेडिकल साइन, रूट साइन नहीं होना चाहिए. तो वी मस्ट रिमूव द रूट साइन. सो पहले इक्वेशन एज इट इज लिखते हैं. क्वेश्चन d2y by dx square is equal to under root 1 plus dy by dx cube. So taking square of both sides. We have to remove the root sign, so taking square of both sides. दोनों साइड का स्क्वायर करते हैं. स्क्वायर करने के बाद इधर लेफ्ट साइड हो जाएगा d2y by dx square ब्रैकेट रेस टू 2 और राइट साइड से स्क्वायर रूट मूव हो जाएगा dy by dx ब्रैकेट क्यूब. अब this is the plane equation. Now we have to find the highest order term. So this is the highest order term. So order is obviously 2. Order इसका 2 है. और what is the definition of the degree? The degree of differential equation is the highest power of highest order term. Means अगर इसका power 3 है लेकिन ये डिग्री नहीं हो सकता because this is not the highest order derivative. Highest order derivative यहाँ है तो highest order derivative का highest power कितना है 2. So the degree of equation is 2. This is the answer. So if you give the correct order, correct degree, 1 mark for each. This is question E in the question number 1. The question is like, show that there exists root of equation x square minus 2x minus 1 in minus 1 and 0. So this is the domain. We have to prove that there exists a root of this equation in this domain. तो इसके लिए क्या करते हैं, पहले फंक्शन लिखते हैं. फंक्शन ऑफ x is equal to x square minus 2x minus 1 और इन दोनों वैल्यूज को उसमें सब्सटीट्यूट करके चेक करते हैं उनका साइंस क्या आते हैं. तो पहले डालते हैं -1, रिप्लेस x by -1, so -1 square -2 into -1 -1. So square is always positive. This will be 1, this will be +2, this will be -1. So 3 minus 1, the answer will be +2. The sign is important. Next अभी वो ट्राई करते हैं 0 डाल के. What value we get? If we put 0 in the function, we get 0 square minus 2 into 2 into 0 minus 1. So first two terms gets cancelled, it is -1. So one value we have got positive and another value is negative. So we can write as function of -1 is equal to positive and function of 0 is negative. So as it changes the sign, it must be crossing to the axis. There must be a 0 between these two values. So the root lies between 0 and -1 or -1 and 0. To solve this problem, this is about tossing of a coin. So the probability of head will be always 1 by 2. Probability of tail also 1 by 2. So p is equal to 1 by 2. Q also 1 minus p. It will be also 1 by 2. Then n, the number of times the experiment is repeated or the number of coins are tossed is 10. So this is binomial distribution as value of n is small. Using binomial distribution formula, PR is equal to NCR dot p raised to r into q raised to n minus r. Now let us put the values. We have been asked to find exactly 3 hits out of 10. So the random variable r will take the value of 3. So it will be 10 c3 multiplied by 1 by 2 raised to 3 multiplied by 1 by 2 raised to n minus r is 10 minus 3. Using the scientific calculator, NCR appears in this button, shift and divided by. And so you press 10, then shift divided by, then 3. You get NCR in the calculator. So this value comes out to be 15 divided by 128. Or if you press SD, it is 0.1171. This is the question number 2A. This question belongs to the integration by substitution. So if we observe the question carefully, we see there is x in both terms. So let us take out that common integration dx over, we take out common x, so it becomes 2 plus log x into the bracket. Now what we can do is we can substitute this whole term as t. This term, if we substitute it as t, the derivative of 2 will become 0 and derivative of log x will be 1 upon x. That x is present here. So let us put 2 plus log x whole term is equal to t. So let's differentiate this term. If we differentiate it, the derivatives of 2 will be 0 plus derivatives of log x will be 1 upon x. So that will become dt by dx. And if we simplify further and cross multiply, dx will become x into dt. Let us solve this problem in this half part. So integral I will become integration of, we have dx, the value of dx is x multiplied by dt, x dot dt, and in the denominator we have x, and we have substituted t for this whole bracket. So here the x term gets cancelled. What remains is integral pure in variable t, dt upon t. So integration of dt upon t is log of t plus c, and we resubstitute the value of t as 2 plus log x, 2 plus log x plus c. So here completes the final answer. I is equal to integration of log of 2 plus log x plus c. This completes the problem. Okay. Let us solve the question 2b from the question paper. This question is again integration by substitution. Here you can see the term tan x repeated twice. We can substitute tan x as t, and the derivatives of tan x is already in the numerator. So let us put tan x is equal to t. Tan x is equal to t. Differentiating this substitution, we get derivatives of tan x is sec square x is equal to derivatives of t is as usual dt bar dx. So we multiply this on left side. So it becomes sec square x multiplied by dx is equal to dt. And so we get the value of dx as dt divided by sec square x. Now let us come back to the integral. The integral after the substitution will look like, so numerator has sec square x, denominator will change. The denominator will become 1 plus t, and next term will be 2 plus t. And this dx, the value of dx will be dt on sec square x. So this term sec square x is in numerator as well as denominator gets cancelled. So we get the complete equation, which is purely in variable t, dt upon. I can write this like t plus 1, as the middle sign is plus, we can write this as t plus 1. and this is t plus 2. Now this integral can be solved in two ways. Either we multiply this and solve by third term method, or we can use the method of partial fraction. Let us use the method of partial fraction, solving by partial fraction. So let us work what's now we will let 1 upon numerator is only dx is 1, t plus 1, t plus 2 as constants is equal to a upon t plus 1 and b upon t plus 2. And let us resolve it into two fractions, find the values of these two constants. So if we multiply by these two terms on the right side, it will look like t plus 1 first bracket, t plus 2 multiplied by these both brackets, a upon t plus 1 plus b upon t plus 2. Now we will multiply these two terms to both of these terms, first and second. So we will get the simplified equation as 1 is equal to a into bracket. When we multiply by a, t plus 1 gets cancelled. What remains is t plus 2. And with b, the bracket of t plus 2 gets cancelled. So the bracket of t plus 1 remains there. So by putting various values in these two equations, we get the constants. This is equation 1. Let us first put t is equal to t plus 1 is equal to 0 or t is equal to minus 1 in this equation. What we get is 1 is equal to a into bracket minus 1 plus 2. And b will become 0 because minus 1 plus 1 will result in 0. And 0 multiplied by something, this will become 0. So it will be 1a. So we get the value of a as 1. Next time we put p is equal to minus 2 so that we could obtain the value of t की जगह minus 2 डालते हैं. So 1 is equal to a into bracket minus 2 plus 2 ये 0 हो जाएगा a और उनको b मिल जाएगा. b के साथ है minus 2 plus 1. इसको सॉल्व करेंगे तो हमको b की वैल्यू मिलेगी 1. ये a 0 बन जाएगा और b multiplied by minus 1. So the value of b will be minus 1 if we shift that minus 1 on the right hand side. So we obtain both the constants of partial fraction. First one is a is equal to 1, here it is, and next constant is. So let us substitute back to integral. Integration 1 upon t plus 1 t plus 2 can be written as t plus 1 multiplied by t plus 2. This both dt can be written as integral of separate integral a is 1 upon t plus 1 dt plus second term b is minus 1 upon t plus 2. And it is very easier to evaluate these two integrals. They simply become log t plus 1 and log t plus 2. So it will put this minus sign placed here, minus log t plus 2. And let's just resubstitute what we have substituted for t. Let us see. We have made t tan x. So let us resubstitute that here. The final answer looks like this. Log of tan x plus 1 minus log of tan x plus 2. We can combine both logs using the laws of logarithm. So it becomes tan x plus 1 in the numerator and tan x plus 2 in the denominator. This is the final answer. Plus c is the arbitrary constant. Here is the final answer of the integral. Let us solve this question 2c. This problem has two functions multiplied to each other. So in integration, if such situation appears where two functions are multiplied to each other and we cannot use any substitution method, then the way to solve such problem is integration by parts. So we are going to solve this problem by integration by parts. So before we actually use the formula of integration by part, we must ensure the sequence of these two functions using, so the rule for sequencing is LIT rule, using LIATE, LIAATE rule. So this rule is actually sequencing rule, where we have to sequence the function as per the rule. Means if there is a logarithmic function, we should keep it to the leftmost side, inverse, algebraic, trigonometric, and exponential function. Now here we have x is algebraic function and inverse is I. This is tan x. So the sequence of function, this is tan inverse x we have. So according to LIT rule, I should be before A. So therefore we are going to change the sequence first, change the sequence and then apply the rule. So this is compulsory, otherwise we cannot solve that problem to the full end. Okay, so we are going to change the sequence and then solve this problem. So the sequence will be I is equal to integration of, there will be tan inverse x before x dot x into dx. So this is the sequence. Now let us use integration by parts rule. Let me write the rule here for your convenience. U into v dx is equal to u into integration of v dx minus integration square bracket, where there will be multiplication of two things, integration of v dx multiplied by derivatives of u. U is the first function, and then again integration of this product of this integral and derivatives. Let us apply this rule to the given situation. It will be like tan inverse x into integration of x dx minus, we will have a bigger integral square bracket, within that there will be integration of x dx, x into dx into derivatives of tan inverse x, first function, that is tan inverse x, square bracket complete, into dx. So again here let us find the integral tan inverse x, integration of x, we use the first formula here. There is no power, means default power is 1. X raised to n is x raised to n plus 1 upon n plus 1 square by 2 minus integral, here again same integration of x is x square by 2, and derivatives of tan inverse x is 1 upon 1 plus x square into dx. We have to again integrate this. So this first term will remain as it is, tan inverse x dot x square by 2 minus, let us take this 1 by 2 constant out. What here remains is x square upon 1 plus x square into dx. So now let's move it upwards. So we will solve the integral by rearranging the terms, tan inverse x into x squared by 2 minus 1 by 2 into integration. So here 1 plus x square, we have x square, we can write it like 1 plus x square minus 1. This will not change its value because we have taken plus 1 and we have balanced it with minus 1. We can rearrange. It is for our convenience. And denominator is 1 plus x square. You can add the same number and subtract from any value. The value remains unchanged. Now tan inverse x into x square by 2 minus 1 by 2. Let us split it into two terms. The first term will be 1 plus x square, 1 plus x square divided by 1 plus x square minus 1 upon 1 plus x square. Now these two terms are easier to integrate. That's why we have splitted it here. At this point we have split it two terms. So this first terms becomes 1. So it is tan inverse x into x square by 2 minus 1 by 2 into square bracket, because there are two terms and this 1 by 2 belongs to both of them. So this gets cancelled. There remains 1 and integral of 1 is x. minus integral of 1 upon 1 plus x square is tan inverse x. It will be tan inverse x plus, so you can keep this as the final answer, or you can multiply by 1 by 2, both of them. Answer remains the same. So such type of one problem definitely occurs in the second question, where how to identify this type of problem? There will be two functions multiplied to each other and there is no sign of any simple substitution there. But remember, if you don't apply the sequencing rule, you will never reach the particular answer. Let us solve this question 2D. So this is question is algebraic function, and for algebraic expression we need this clear. So we take this 2 out, 1 by 2, take out common, integration of dx upon. So when we take common, we actually divide each term by that common term, x square plus 3x by 2 plus 1 by 2. Now we will go for the third term. In order to complete the square, we need third term. The formula for third term is 1 upon 2x into middle term and whole bracket square. So in your middle term, our middle term is 3x by 2 and whole bracket square. Let's cancel. It is 3 by 4 and the square of 3 by 4 is 9 by 16. So the third term, if we add this term to first two terms, we will get the complete square. Let us see how it progresses. So the integral will now become r is equal to integration of dx over, here is 1 by 2 outside, x square plus 3x by 2. Here we add the third term. The objective of adding this third term is to make the complete square. तो इन तीनों टर्म को कंप्लीट स्क्वायर बनाने के लिए हमने ये थर्ड टर्म ऐड किया, फिर उसको वापस देना भी पड़ेगा क्योंकि हम इसकी वैल्यू नहीं चेंज कर सकते. सो 9 by 16 माइनस भी कर दिया. तो अब ये दोनों टर्म को एक साथ रख लिखेंगे और पहले तीन टर्म्स जो है इन तीनों को हम लोग स्क्वायर के फॉर्म में लिखेंगे. इंटीग्रेशन dx over. So the first three terms, it is perfect square of x plus, take x from here, sign from middle term, and the root of this, it is 3 by 4 whole bracket square. So let us check it. X plus 3 by 4 whole bracket square. What will be? A plus b bracket square is a square plus 2 into ab is x, b is 3 by 4 plus b square. B square is 9 by 16. So these two will get cancelled. So it will be 3x by 2. So it is x square plus 3x by 2 plus 9 by 16. So this all three terms become this single term. Okay. And now next two terms, 16 1s are 16, 9 2s are 18. So it will be minus 2 by 32 or 1 by 16. You can use calculator. Calculate this 1 by 16. The combination of last two terms. Now this exactly is the formula of integration dx upon x square minus a square. This is a standard formula. So we have reduced the expression, our integral, to this standard form. The formula is 1 upon 2a log of mod x minus a upon x plus a plus c plus c. Now note the difference. Instead of x, we have this whole term. This whole term is our x square minus a square. This is square of 1 by 4. 1 by 16 is 1 by 4 square. So the strap line formula, it will look like this. 1 upon 2 into a. What is a? A is this 1 by 4. This is actually square, we could have written it like this also, 1 by 4 bracket square, 1 by 16 in the field. So x square minus a square. So a is 1 by 4, 1 upon 2a into log mod of x. What is x? X is x plus 3 by 4. This is x minus a is 1 by 4, x plus a plus 1 by mod complete plus a. Okay, let's simplify it a bit, but get the final answer. So this 2 into 2 to the 4, and this 4 gets cancelled. Nothing remains there. So what remains is log of modulus of, this is denominator is same, 3 minus 1 is 2, 2 by 4 is 1 by 2. X plus 1 by 2 upon, in the denominator 3 plus 1 is 4, 4 by 4 is 1. That results in x plus 1. This is modulus plus c. This is the final answer. So this type of problem is also called completing square problem. How to identify? It is an algebraic expression, or simply it looks like a quadratic equation, ax square plus bx plus c, quadratic term. That term, if appears, we have to take out common, then use the third term, and add third term, subtract third term, complete the square, and then use the appropriate formula. There are 3 such formulas. This is second one. One is dx upon x square plus a square, that results in 1 upon a tan inverse x upon a. This is second one, and third one is a square minus x square. Students have to memorize all 3 formulas. So this is question number 3A on the question paper of summer 2024. Such question is to be solved by a particular method. To identify this question, numerator in the denominator, there must be either cos square x or sin square x or both terms. So the standard method to solve this is divide each term in numerator and denominator. Divide each term, हर term को divide करना है cos square x. ये standard method है by cos square x. और फिर बाद में उसको substitution method से solve करें cos square x. So if we divide each term by cos square x, the integral will look like 1 upon cos square x. dx आगे लिखते हैं तो वहां 1 बचेगा, तो 1 को हमने cos square x से डिवाइड कर दिया. This will be 4 cos square x divided by again cos square x. Each term, हर term को numerator और denominator के हर term को cos square x से डिवाइड करने का. 9 into, here it will be sin square x divided by cos square x. ऐसा करने से ये इंटीग्रल इजी फॉर्म में आ जाएगा और we can solve it by substitution method. Cos square x, okay, into dx. After dividing this, the reciprocals 1 upon cos square is nothing but sec square x. These are the trigonometric reciprocals. 1 upon cos square का मतलब होता है sec square x. डिनोमिनेटर में कुछ टर्म्स कैंसिल होंगे और कुछ cos square x कैंसिल हो जाएगा, only 4 will remain, plus इधर में sin upon cos is tan, so it will be 9 tan square x. This will be the second term. Now this problem has reduced to the problem of substitution. Now if we substitute tan x for t, we get sec square x, its derivatives, and we can solve it by substitution method. So let us put tan x is equal to t. Derivatives of tan x is sec square x is equal to dt by dx. And if we take dx on left side, the value of dx will be dt upon sec square x. dt upon sec square x. If we take on right hand side, तो वो डिनोमिनेटर में चला जाएगा. अब ये दोनों वैल्यूज आने के बाद नया इंटीग्रल जो बनेगा, इट विल बी इन टर्म्स ऑफ टी ओनली. सो नया इंटीग्रल इस तरह बनेगा, i इज इक्वल टू न्यूमरेटर इज sec square x, डिनोमिनेटर में इधर लेफ्ट हैंड में we have 4 plus 9 t square, 4 plus 9 t square, and we have value of dx की वैल्यू इधर मैंने निकाली है dt upon sec square x. So this value of sec square x gets cancelled and the integral becomes simple, 1 upon, I'm writing this term before, 9t square plus 4. This is simple integral of algebraic type. We can solve it by standard formula. In standard formula, we need square term clear. Means this 9, we will take it out as common term. So it will become 1 upon t square plus 4 upon 9 into dt. Or we can write dt here also. So this reduces to, let us write it in the form of squares. 1 by 9 into integration of dt upon t square plus 4 by 9 is 2 by 3 bracket square. We need both terms in terms of square. And here there are 3 formulas. We are going to apply first formula out of it. Let me write the formula here. The formula here is, there are actually 3 formulas. The first one is this dx upon x square plus a square. The next one is dx upon x square minus a square, and so on. These 3 formulas every student must have memorized. So this formula is 1 upon a into tan inverse x upon a plus c. Let us apply this formula to our situation. So our integral will become 1 by 9 is already common term. 1 upon a is the next term, 2 by 3. So 1 upon 2 upon 3 into, where it will be tan inverse x upon a. X is p. This is x and this is a. So t upon it will be 2 by 3. This plus c. Simplify this. This 3 gets cancelled. It is 3, 3 2 is 6. You can use calculator here also. It will be 1 by 6 into tan inverse. This 3 goes to numerator. 3t upon 2 plus c. Let's resubstitute back what we have substituted for t. Let us see what we have made t. So we have put tan x is equal to t. So let us resubstitute that back. So the final answer will look like 1 by 6 tan inverse 3 tan x upon plus c. This is question 3b. And the question back, this is based on the property of definite integral. This such type of problem is relatively very easy to solve. So we rewrite the given expression, given integral, and name it equation number 1. Now here we use the property of definite integral, that is integration a to b function of x into dx can be written as integration a to b function of a plus b lower limit plus upper limit minus x. Writing in this manner doesn't changes the value of integral. So we will apply this property to our integral. The lower limit of our integral is 0, upper limit is pi. So the integral after applying the property will look like this: 0 to pi under root 9 minus x. So wherever there is x, we will replace it by a plus b. B is pi minus x. So simply you can ignore 0 and write pi minus x also. So at all 3 places, we will apply the same thing. Here also under root 9 minus 0 plus pi, or simply pi minus x plus under root x. X will be replaced by 0 plus 5 minus x and plus 4. It is x plus 4. This all is x into dx. So this new integral, let us simplify it and see what value it gives us. In all such problems, we get the same integral but with changed terms. this 9 minus x will become x plus 4, and this x plus 4 will become 9 minus x. It happens in almost all problems. So the integral, if you simplify it, it will change. See, if we simplify it, let me do it in here. If we simplify it, 9 minus 5 plus x. So it will change to 4 plus x, or we can write it as x plus 4. So there is interchange between the terms. x4 plus 4 will become 9 minus x, and 9 minus x will become x plus 4. This happens in all problems, remember. So it will be x plus 4, and in the denominator also the terms get interchanged. This is x plus 4 in the under root, and this x plus 4 will get changed to 9 minus x. So we call this equation as equation number 2. Now simply if we add these both equations, we reach to the solution of this equation. The steps are same for all types of problems, whatever it may contain. So adding equation 1 and 2, if we add these two equations, on left side it will be I plus I, and on the right side there will be two integrals. First one, original problem, that is under root 9 minus x, and denominator is under root 9 minus x plus under root x plus 4 dx. This is integral from equation 1, and we have the second integration 0 to 5. Second is interchanged expression. So we have x plus 4 in place of 9 minus x. After applying property, the terms gets interchanged. The same thing happens in almost all problems. Under root x plus 4 plus under root 9 minus x. Now if you observe these two integrals carefully, the denominator of both of them is same. So we can write here on left hand side it will be I plus I 2I, and if we add these two integrals, it will be denominator is same, the terms are interchanged. So we can write under root 9 minus x plus under root x plus 4. And in the numerator, if you observe, it is also same, under root 9 minus x plus under root x plus 4. This also happens in almost all problems. The terms gets interchanged into dx. And in all problems, this whole bracket gets cancelled. This whole bracket is cancelled because it is same. This happens in almost all problems. So the problems reduces to simply 1. So 2i is equal to integration 0 to 5. अब यहाँ सिर्फ 1 बाकी रहेगा. 1 का इंटीग्रेशन निकालना है x. So its integration will be simply x, apply the limit, and applying the limit, upper limit minus lower limit. So, but remember it is 2i. Some students will forget to take this 2 on the right hand side. So the value of final integral I is 5 upon 2. Such problems, there are two types of such problems. One is algebraic function. This one was algebraic, and there is one trigonometric, in which the sine and cos gets exchanged. So this problem, there is a hint. You can know the answer without solving it. The answer is simply b. If this limit is a to b, b minus a upon 2. For all problems, the answer is b minus a upon 2. But we have to solve all these steps, then only we will get the 4 marks. So let us solve this question 3C. Question number 3C in the question paper. This question is from the chapter differential equation, and in that this belongs to the exact differential equation. So the standard format of exact differential is m dx something into dx and n dy. M and n are the functions of x and y, and dy is equal to 0. So in exact differential equation, we have to solve the problem in 2 steps. The first step is to check whether the equation satisfies the condition for exact. So let us check for exact, and then in next we solve the equation. So first step we go for check for exactness of the equation. So the exact, in order to check for exact, I need to find the partial derivatives of this both term m and n. So let me write what m is. M is equal to 3x square plus 6xy square. And in other half part, we will solve the part n. And n is 6xy square, x square y plus 4y square. So we have to find the partial derivative of this m with respect to y. Now this is the symbol for partial derivative. One is the full derivative and this is dou for partial derivative. What is the meaning of partial derivative? In partial derivative, we differentiate only y term and treat x as constant. So let me mark the constant terms here. So this 3x square is a whole constant term, and here 6x is a constant term, and we treat this as a variable. So let us partially differentiate. So rule of derivative is, if there is a complete constant term, the derivative of constant is always 0. Plus, here it will not become 0 because constant is accompanied by a function. So it will be 6x multiplied by 2y. So the final partial derivative will be 12xy. Similarly, let us find the partial derivative of n with respect to x. This is the rule for checking the exactness. These both partial derivatives must be same, then and then only the equation is exact. So let me mark the constant. Now we are going to differentiate with respect to x. So the y terms are treated as constant. These both are constant and this complete term is constant. So constant term, let me write 6y, and I differentiate x square. Derivatives of x square is 2x. Plus this is constant alone. Remember the difference here. Why 6y did not become 0? Because it has function with it, and here there is no function. Whole term is constant, so the derivatives of constant is 0. So we result in 12xy. So now from this we can write the interpretation that as this must be written, this carries the half marks. Partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Given equation is exact. If there is even slight difference of sign, it will not be exact. Given equation is exact. So this is the first part of solving this differential equation, and this carries 2 marks. Now let us move to the second part of this problem, that is the solution of this exact differential equation. So the formula for solution of exact differential is integration of m dx plus integration of n dy is equal to c. Here there is condition for integrating m, keeping y constant, keep y term as constant, This is the rule, and in n we choose the terms free from x. Only terms in n which are free from x. There should not be x terms taken in account. Moving further, what is m? Let us write m. M is 3x square integration of 3x square plus 6xy square into dx. Now we will integrate this keeping y as a constant, and plus what is n? N has two terms actually. The first term is 6x square y and second is 4y square. But we are not going to take 6x square y because it contains x. So here there will be only one term, that is 4y square into dy. That is equal to c. Now integrate this 3x square. Integration 3 is constant. Integration of x square is x cube upon 3. Formula is, first formula x raised to n. Then here 6y square we treat it as constant, so we will keep it as it is, and integration of x is x square upon 2. Here 4 is treated as constant and integral of y square is y cube upon 3 is equal to c. Remember here very basic first formula of integration is used, which is integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1. This is most fundamental and first formula of integration. We have used it here, we have used it here and here. Okay, further simplifying, this 3 gets cancelled, this 2 gets cut with 6, it becomes 3. So the final answer, final solution of this differential equation, x cube plus 3x square y square plus 4y cube upon 3 is equal to c. So this is the general equation from which that differential equation has been formed. Means if we differentiate this and go on differentiating this, we reach that differential equation which was given for us to solve. Okay, so such type of one problem appears in the examination that belongs to this category of exact differential equation. Now let us solve this fourth problem in question 3. This question belongs to the chapter of numerical methods, and in that we have been given an algebraic equation. We want to find its solution. So this problem is solved in 2 steps. Step 1 is to find the root lies between, means the domain of the function in which the root lies between. To find the root lies between, or to find the domain where the root lies. For this we write the original function f of x and then test various values in it. Original function is x cube minus 2x minus 5 is equal to 0. Let us start from 0. We will go on changing the value till the function changes its sign. So f of 0 will be, this will be 0 cube 0 minus 2 into 0 0, and this is minus 5. So the final answer will be minus 5. Function of 0. Let's test function of 1. If we put here 1, it will be 1 cube minus 2 into 1 minus 5. So 1 cube will be 1 minus 7, it will be minus 6. Now next f of 2. Function of 2 will be 2 cube minus 2 into 2 minus 5. So this will be 2 cube will be 8 minus this 4 minus 5 9. So it will be minus 1. So next let's try next value, f of 3. So it will be 3 cube minus 2 into 3 minus 5. ये कहाँ तक जाना है? Till we get the change of sign. Means the sign is negative, negative, negative. Where we turn positive, we will stop there. Let us calculate this using scientific calculator. Over here we go for 3 cube minus 2 into 3 minus 5. So it comes out to be plus 16. So here the function has changed its sign. negative to positive. Means 0 will lie somewhere in between. So we write root lies between 2 and 3. This is the first part of the problem. We have to find the root lies between, or the domain of the root in which the root lies, 2 and 3. The next part is the part of calculation of by iterations. So part 2 is iterations. Here we go on iterating, and for this there are different methods to carry out the iterations. The easier method I think is the tabular method. So let's make a table and use the tabular method. That is relatively easy. Let's make the table using the ruler. One A, then one for B, then we are going to calculate x, then we are going to calculate the function of x and then its sign. This method is relatively easy as compared to the non-tabular method. You can solve it by both methods. The answer comes out to be the same. Okay. So here what we write is a. We consider a the value whose function is negative. We consider b the value whose function is positive. And then we calculate x as x is equal to, bisection method has this formula, bisect, means make two parts, a plus b upon 2. Then we will find its function f of x, as f of x is given as x cube minus 2x minus 5. And we are interested in sign of this function. Okay. So let us write a will be, whose function is negative 2, a is equal to 2, a is equal to 2, b is equal to 3. So we start our first iteration, x is equal to a plus b upon 2, 2 plus 3 upon 2. So it will come out to be 2.5. Now we test the function of 2.5. That will be 2.5 cube minus 2 multiplied by 2.5 minus 5. Let us use the scientific calculator for this purpose. We change the value of 3 by 0.5. That results in 5.625. 5.625. 5.625. We're interested in sign of this function, so the sign comes up to be positive. So here completes our first iteration. We'll mark a line here. This is iteration number 1. And for iteration second, if this sign is positive, we change the value which has positive function b. So b will be replaced by 2.5. So new b will be 2.5 and a remains unchanged. A is equal to 2. If this value might have come negative, we may have changed value of a. This is very relatively easy method. We carry on the same steps to find the center of these two, दो और 2.5 का सेंटर निकालना है. That's why it is called bisection. Bisect का मतलब है दो पीस का. ये 4.5 हो जाएगा, 4.5 का हाफ 2.25. अब इसका फंक्शन चेक करेंगे. We'll check the function of this. 2.25 का क्यूब minus 2 into 2.25 minus 5. Let us use again scientific calculator for this purpose. इसी में बैक जाके 2.5 की जगह 2.25 करेंगे. 2.5. Okay. The answer comes out to be 1.890. The answer of function is 1.890. We're interested in sign of this. This also turned out to be positive, which indicates that the root lies between 2 and 2.25, since it is positive. So we change the positive, and this completes our second iteration, iteration number 2. And here we change this one. The new b is 2.25, and a remains unchanged because the function turned out to be positive. This may have negative. अगर negative आता तो हमने a को change किया. अब x कैलकुलेट करते हैं. इन दोनों का सेंटर x is equal to 2 plus 2.25 divided by 2. तो इसका आंसर आएगा 2.125. That is 2.125. And this is the final answer. As we complete the third iteration, we no need to calculate further any function or something. So this completes the answer. So after the iterations, we can conclude that approximate root approximate root of equation is 2.125. So this is a 4-mark problem. So there are 2 steps. The first part is finding out the domain in which the root lies, and second part is actually carrying out the iterations. Okay.